Welcome, everyone. A very warm welcome from myself, Rick, and the entire Hopsworks team. We're here today to talk about a topic that is extremely dear to my heart. We're going to talk about machine learning with Neo4j Graphs and how that can help us make and provide and productionize better machine learning systems. That's the topic, and I am really looking forward to it. And part of the reason why I'm looking forward to it, and part of the reason why it's dear to my heart, is obviously because I have a long history with Neo4j. Some of you may know me already. If you don't, uh, obviously, no problem at all. So I work for Hopsworks since November of last year. I lead the commercial team, the go-to-market team in Europe and Asia. But before that, I was working for Neo4j for more than 10 years. And as you can see, I wrote two books about Neo4j, two versions of the same book, I should really say. There's a third book, a Neo4j for Dummies book that I wrote together with Jim Weber, who is the chief scientist of Neo4j. And I obviously also kind of made a little bit of a name for myself in those days because when I started working for Neo4j in 2012, we really didn't have any kind of a demo for Neo4j. So I had to kind of pull myself up by the bootstraps, and I created something that haunted me for many years, which is a beer graph, right? A graph of Belgian beers. I live in Belgium. I'm a how do we say that? I'm a happy consumer of Belgian beers. And I created a graph database of Belgian beers and went around the world talking about that for quite some time until I got a little bit of a reputation. And that history is kind of relevant because, when we started with Neo4j in 2012, it really was a very different tool from the tool that we know today. Neo4j, the graph database, was actually something that was founded by Emil, Johan, and Peter in 2000 already. They really were a bunch of Swedish developers that were scratching an itch, a fantastic open source project at the time. But by 2012, it became more of a commercial offering, and we really wanted to, sing the song of graph databases to a much wider audience. And so that's where the beer graph came in, because I wanted to show it to people in a way that people would understand in a very, very easy way. And then, this kind of succeeded. The company grew and grew, and by the time we got to the early 2020s, it was a very different capability that we were providing to customers at the time. And this is my personal experience, obviously, but one of the things that was fantastically different by that time is that Neo4j moved into the realm of data science, right? In 2020, they launched the Neo4j Graph Data Science Library, GDS. And in 2022, that became a graph data science as a service offering, right? Now, this is very logical in my head, because always, from the early days onwards, we always kind of knew that, graphs intrinsically have fantastic powers, right? When it comes to performance, for example, right? We always talked about the joins, right? The database joins that you could do in Neo4j at an unbelievably high speed, right? Right? Why? Because, you would basically pre-calculate the joins and persist them as relationships, right? They have semantic powers, right? Because it makes complex information really easy to understand. But one thing that kind of became really, really apparent, as people started to use it more, is that they have predictive powers, right? You can predict what's going to happen, especially when, things like COVID happened in 2020, it was unbelievable how we were able to predict, how, for example, the diseases were going to spread through communities, through the graph, basically. So already at that time, it was kind of logical that people would use graphs for predictive applications, machine learning applications. And that's where the data science toolkit came from, obviously, right? So this webinar, what we're going to be talking about is how you can use the power of the graph of Neo4j and embed it into a broader context of machine learning so that we can provide our organizations, our government institutions, or whoever you work for with better predictions, right? Now, to talk about that, I think it's useful to zoom out a little bit and look at what's happening in that broader landscape, in that broader machine learning landscape. And obviously, this is now talking to you from a Hopsworks perspective, because Hopsworks really is a platform for productionizing and developing and spreading these machine learning systems, right? And I think from a perspective of Hopsworks, we've kind of seen that the benefits of machine learning have become extremely clear over the past couple of years, right? As you move from experimental applications on static data to systems that use batch data, right? That you apply time and time again in pipelines, and you move into real-time applications, right? It becomes abundantly clear that machine learning has reached a maturity level that offers extremely large benefits to organizations, right? We can process more data, we can process it better, we can do it faster, we can enable better decisions, we can drive efficiency and innovation, right? Especially now that we are including things like large language models and generative AI applications as applications of machine learning, right? It becomes abundantly clear that there's an enormous amount of benefits to be had here. But there is a but, right? What's also abundantly clear is that these systems are quite complex, right? If you're only talking about machine learning on one type of system, let's say a Neo4j graph database, then obviously, that becomes fairly simple, right? Machine learning on one data source, on one type of application, on one type of environment is kind of manageable, right? But what you find is that that's not how these real systems are developed, right? They have lots of different data sources. There's lots of ecosystem integration that needs to happen in order for a real machine learning application to be put into production. Data is coming from different sources at different cadences with lots of different data types, different data schemas. All of this stuff is quite complicated, right? Complexity has risen there. And therefore, at the same time, or I shouldn't say therefore, but at the same time, the engineering complexity of these systems has also risen, right? This is not something that is easily put together. Sure, you can do this, on a one-on-one basis, right? You can tie one system to another system and have one fairly simple machine learning system be developed quite easily. But if you want to do it a little bit more generically, right? If you want to have some kind of, shared infrastructure for these types of systems, you will find that the engineering characteristics of these systems are quite complex. There's a lot of moving parts, right? There's, all of these different logos that you see on this slide that need to be integrated from an engineering perspective, in order to build these types of systems, right? And then we're not even talking yet about the operational complexity, right? So Yes, we have fantastic value, right? But the ecosystem is complicated, the integration is complicated, and operationally, in order to run these things, right, 24/7 across data centers, across time zones, across continents, right, it becomes quite an interesting challenge, right? Not just, as a system that needs to be running all the time, but it also needs to be governed, right? You need to be understanding what goes where and who owns what and which version are we working for. We need to be responsible about these systems. We need to be, able to explain these systems. All of these things come into play here. And last but not least, I would like to add that I have seen a number of organizations out there where machine learning has basically it has become something that is operationally sound. People want to do it, and it makes sense to do it, but the price tag of these systems has become quite extravagant, right? So this is the environment where we're living in. We're living in an environment where, yes, there are fantastic benefits to be had, right? But the complexity has soared, right? And at the same time, we need to drive for efficiency, cost control, accuracy, and we need to be able to guarantee explainability, trustworthiness, and governance, right? So we're in a little bit of a complex environment here, right? And this is obviously where we hope to help the industry with some of the Hopsworks tools that we are going to provide, right? This is where we are at today, right? With Hopsworks, we think we can provide you with a solution that brings you a cost-effective AI factory, right? For your private data, for your private AI and ML systems, right? And we will do that around something called a feature store. And I will try to explain that a little bit later as well. Right? By doing this, we're going to drive performance into these systems, right? We're going to make sure that you can develop these systems more quickly, right? More efficiently. You can run them faster, right? We're going to be able to share infrastructure across all of your different models, right? On a robust platform, right? That is basically going to help you accelerate the adoption of this wonderful new technology. We're going to try to get rid of all of this complexity and replace it with efficiency, effectiveness, and governance, right? Now, this is obviously a bold claim that we're making here, but we can substantiate that as soon as we start looking at some of the details of how the underlying platform that Hopsworks provides, how it fits together. What you will find is that you will recognize a lot of tools in there. There's a lot of capabilities in the Hopsworks infrastructure that is going to help you put these systems together across all of your applications, right? And you're going to find that all of the integration between the different components has been done for you, right? So we will already provide you with your Jupyter notebooks. We will already provide you with your data storage platform. We will already provide you with your Airflow directed graphs. All of these things are going to be provided to you pre-integrated by the Hopsworks platform. And like I said earlier, kind of the secret sauce to how Hopsworks does this is by providing something called a feature store. And I'd like to get into a little bit more detail here because it's a really nice way of also explaining where the synergies with Neo4j Graphs are, right? So what we're going to do with Hopsworks is we're going to basically recommend that you structure your machine learning into modular pipelines, right? into pipelines that, don't form like these big monolithical scripts and everything. No, they're going to be a lot more easy to digest, easy to manage, easy to work with, because they are going to be separated into 3 different types of pipelines, right? So the first pipeline is what we call a feature pipeline, right? And a feature pipeline is going to prepare all of your data, right? Transform it in such a way so that it's ready for you and your machine learning applications to consume it, right? You're going to transform the data that you have, like let's say that you're starting from a list of transactions. Well, you're going to prepare that data in such a way that it's ready for your machine learning applications, right? And of course, these feature pipelines will provide this feature data to the feature store, right? The Hopsworks feature store is going to take care of the storage of both the historical data of your features and the most recent online data that you need for your immediate predictions, right? The second pipeline that we're going to be structuring your machine learning applications into is what we call the training pipeline, right? Where you train the models using the features that you get from the feature store in order to kind of see how you can detect patterns in those in that training data. And with those patterns, you can use those patterns to make predictions for the future, right? So there's an interaction between the feature store and your training pipeline. You will use the appropriate set of tools to do the training, and you can run that on top of any compute infrastructure. Could be Hopsworks, could be something else as well. And you basically develop the model there, right, using your training algorithms. Once you have done that, you will basically store that model in the model registry of your feature store, and then start deploying those models for your third pipeline, which is your inferencing pipeline. And the inferencing pipeline is what you will use to make predictions using those models and the latest versions of the features for your end customers. Right? Those predictions could be batch-oriented, they could be real-time, it could be all kinds of different things. Now, having explained the nature of the platform like this, right? So there's a feature store that holds all of your data, right? And there's these 3 different pipelines that allow you to structure your machine learning applications in a really, really easy to understand way. It also becomes much more easy to understand how Neo4j fits in here, right? What we're going to do with graph data coming from Neo4j is we are going to use those graph data sets to make better predictions, right? And we're going to use those data sets, we're going to use that graph data to productionize the use of that graph data and prepare, the predictions for real-time usage in production applications, right? So we basically want to bring Neo4j in, right? We want, if I fill in the blanks here with Neo4j, right? Neo4j is going to be one of the input sources of data that comes into our feature pipeline, right? We can use something like GDS, right? The Graph Data Science Toolkit, to pre-process the data in a way that makes it suitable for consumption in our training and prediction pipelines, inferencing pipelines, right? And for example, something that we'll use in the demo a little bit later on is we can use something called graph embeddings, right? In GDS, you have a particular set of really interesting algorithms that were added, I want to say like 2 years ago, that calculate embeddings for graph data. Embeddings are like vector representations of the structure of the graph in such a way that you can actually do algorithmic calculations on it, right? So this is a perfect way of putting in the graph data into the pipeline, right? So in the pipeline, you will work with the embeddings. We will use those embeddings to do the training, right? To do the training of the models, and then we will do the inferencing and potentially feed it back, that inferencing, into Neo4j or into other applications later on, right? So if I look at this in a little bit more detail, right? What will happen here is using data that are coming from Neo4j in the feature pipeline, we will create feature groups, right? In the feature groups, we will store the data so that it can both be historical data and the most recent data that we can use for our model training. And once we have trained the model, we will register that model. And once we have it registered, we can use that for deployment and actual inferencing and predictions, right? So this is what we're going to be looking at a little bit later on. We've prepared a short little demo here. And essentially what you will see is that, we will really see the feature store and the model registry at work here, right? Where we will have different data sources, both tabular data sources and graph data sources that come together in one feature store system. In that feature store system, we will develop the model, we will deploy the model, and we will use it to do predictions. All right, that's where we are right now. I'm going to take a little sip of water, if that's okay. And then we can continue. All right, let's go. I would like to highlight that you can actually go and replay everything that you will see here today in our demo. You will be able to go to the Hopsworks tutorials GitHub repo, right? So you go github.com, logical clocks, that's the old name of our company, and then Hopsworks tutorials. You will see that there's an integrations directory here. And in the integrations directory, there's a Neo4j subdirectory that you can use. What you will see, and this is for all of the Hopsworks tutorials, we try to make it really easy. We structure everything into notebooks, right? So the first notebook is a feature engineering notebook, right? Where we basically connect to a Neo4j database, and we go through all of the steps that you have here to get the data into Neo4j and then from Neo4j into the feature store, right? And then we have a training pipeline, right? Where you go through the steps of pulling the data from your feature store, selecting the right features, and then, basically creating a feature view from it, creating a training data set from it, and then building a model from it, as you can see over here. And then the last part is an online inferencing notebook where you can actually use this yourself, right? And use this newly built model for predictive tasks. When I say you can go there and you can use this yourself, well, you can actually do that by using our serverless version of Hopsworks. Hopsworks is quite a complex system. There's a lot of moving parts, but we offer a free online serverless version of Hopsworks that you can just log into. There's no credit card required here. You can just go here, and then you will have a project in which you can basically take it for a spin, create features, feature groups, create feature views, and do everything that you can normally do, except you will not have any kind of compute environment. You will have to host the compute of your different machine learning pipelines somewhere else. That could be Google Colab, could be your own notebook server, could be your own Python environment, could be Visual Code, Visual Studio Code. It could be whatever, right? But if you use the app environment of Hopsworks, you will not be able to run any compute. You will see that, for example, here, the Jupyter notebook has been grayed out. That is not the case when you have a commercial version of Hopsworks, right? And that's what I'm going to use now. I will have a cluster, a managed cluster of Hopsworks, which is running on this location over here, and upon which I have multiple projects, right? And I'm going to show you how we can work with these projects in combination with Neo4j, right? So let me show you a little bit of what we'll try to do here, right? So I've got a Neo4j Aura environment over here, right? And I'll actually load some data into it, right? So I have my user interface. There's nothing in here right now, right? This is just an empty Aura environment. The property keys that you see here, that's because I was using the same environment before, and the workspace preview of Neo4j is still caching that. So what I'm going to do, well, first thing that I'm going to do is I'm going to create some constraints in this Neo4j database, and then I'm going to load some data in it. The first thing that I'm going to load is I'm going to load some parties, right? So I've got a party.csv file over there, and I'm going to load these parties, right? So now I have 7,000 nodes in my Neo4j database, right? They have a couple of properties here, but that's about it, right? Then I'm going to load some transactions, right? So I'm going to load the transactions. This is a little bit more of a bigger data set, and I also need to connect those transactions to different parties. So there's a little bit more involved here. And so this transaction, this loading procedure will take about 20 seconds normally, right? So I load the relationships between the parties, right? So the model, the graph model that we're looking at here is we've got party nodes connected by transaction relationships, right? And so if I go back here now, I already see a few appearing here, right? So I have my nodes, right? And I have relationships between them, transaction relationships. I can double click them and see what how these things are related to each other. And you see multiple transaction relationships between different parties, right? So by now, this has completed, right? So I have 438,000 relationships here. And what I'm going to do next here is, and by the way, I can do this from a Python script on my Hopsworks environment as well. But I'm assuming that many people in this webinar have some affinity with Neo4j. So I'm trying to show the native Neo4j environment. So the first thing I'm going to do next is I'm going to load a GDS graph projection, right? Which is not supposed to happen. Let's see here. Oh, the transaction graph already exists, so I'm going to drop it first, and now I'm going to load it again, right? So I've got a new transaction graph in memory projection in GDS now. And then the next thing I'm going to do is I'm going to basically calculate the graph embeddings, right? What you see here is I'm going to use a GDS node2vec to create a new property, node2vec, right, on the party nodes, right? So if I go to the party nodes over here, you will see that it doesn't have any node2vec properties yet. However, if I now go and I run this, right, it will write these properties to the party nodes in Neo4j, right? So now I go back here and I will see that all of a sudden I have a node2vec property on every one of these party nodes. And this is important, right? Because the node2vec property is what I'm going to use in my machine learning pipelines, right? I'm going to pull this from Neo4j into my Hopsworks feature store environment so that I can make better predictions for my, in my case here, it's going to be an anomaly detection use case that I'm going to use to basically use that and make better predictions, right? So you see that in Neo4j, we already have these Node2Vec properties, right? So that's great. Now I'm going to switch back to Hopsworks. I'm going to show you how we work with this, right? So in Hopsworks, I have already, done this a couple of times now. What I have over here is I have multiple feature groups, right? So I have the overview of all the transactions per month, right? I have the labels of all the different parties, and I have the graph embeddings. But what's cool here is that, this data, these are feature groups, right? I can see all of the details of this data here, right? If there is any provenance data, I can show that over here. If I have any validations that I want to run, right? So a feature store, one of the cool capabilities of a feature store is that it will allow you to validate whether or not the data is adhering to the rules that you want from it, right? You will also make it searchable by adding tags to it, right? You will have alerts, right? Saying, okay, every time I import data into the feature store, does it adhere to these rules? Okay, if not, I want to have some kind of warnings that are triggered. And I actually have that integrated with our Slack environment, for example, or my email or whatever it might be, right? I also can show you that there's multiple versions of the different data sets here, right? So I have multiple versions so that I can basically run the entire explainability chains. I can run them on the versions of the data that I have used for example, for my training, right? So now you see the feature groups here. I have my feature views as well, right? So this is what I'm going to be using for my training data, right? So it's going to show me, okay, this is where the data is coming from, right? These are the feature groups, right? And the feature groups are going to be put together into a feature view, right? The feature view is basically a putting together of the data into a data set that can be used for training. Then I use the training data set, and this is what I'm going to be using for my different models, right? So let me show you this in a little bit more detail. On this environment, so on the serverless environment, you have the Jupyter environment grayed out, but on this environment, I have the Jupyter environment running over here. For those of you that are not familiar with this, Jupyter is a way for you to run Python code really, really easily. And with this Python code, I can now basically engage in these different machine learning pipelines really, really easily. As I showed you earlier, we have these three pipelines, right? We have a feature engineering pipeline, we have a training pipeline, and we have an inferencing pipeline. And this is how we structure all of our modular machine learning systems, right? So what I'm going to do now is, and I really want to give you a short version of the demo, because otherwise it would basically take us a little bit too long. But what I'm going to do is I'm going to update, actually what I should do here is I need to restart the kernel and clear all the outputs. Right? This will only take a second. Right, so on my Jupyter Lab implementation, I can now do the appropriate imports, right? So this is pure Python code, right? This is the cell that I'm executing, right? And then I have my connectivity to my Aura environment, right? And then here, this is the Python code that I can use to update the Neo4j data, but I've already done that in the native environment, so I don't really need to do that anymore, right? What I'm going to do next is I'm going to pull in some other data into a data frame, right? So you will find that Hopsworks is a Python native environment, so I can just pull this data into data frames, right? And then when I do that, it makes it really easy for me to do some remaining operations and potentially update the data, right? So this is where Hopsworks starts coming in, right? I'm going to connect to Hopsworks, right? So this is super easy. Import the Hopsworks library, grab the project, and then grab the connection to the feature store. And then I can run the validations, right? So as I showed you earlier, we have a tool called Great Expectations, fully integrated with Hopsworks, which allows me to verify if the data is adhering to the rules that I have for it, right? If it does, then happy days, and I can continue. And now here, what I'm going to do is I'm going to read the embeddings that I calculated, right? So here in the Neo4j environment, I have my Node2vec embeddings, right? I'm going to pull that from Neo4j, right? So what I do here is I run this query, right? I can run this query over here as well, actually, right? So you can see what the graph embeddings are going to look like, right? So what it's going to do is it's going to pull the ID, the party graphs embeddings, and the timestamp, right? I'm going to do exactly the same here, right? So this query over here. And when I do that, I pull that into a data frame, right? So my Hopsworks instance is now connecting to my Aura instance. It's running the query, and once it's run the query, it puts the data into a data frame. And once I have that, once I have it in the data frame, and this is taking a little bit too long for my tasting, but once I have that, I can grab the data frame and basically do one more operation on it and put it into a feature group inside Hopsworks, right? So this is now done, right? So this is what I had. This is the equivalent of the query that I showed you here, right? So the ID, party graph embedding, and transaction timestamp, right? I have that here as well, right? And this is what I'm now going to manipulate one more thing. And then I'm going to store that into the Hopsworks feature group, right? So when this is done, right, you can see how many rows are being uploaded, right? So this takes a couple of seconds here. Once it's done, you will see that in the Hopsworks environment, I will see an ingestion job, right? So this is my Hopsworks environment, and I will have a new job, right, that has been started here, right? So it's this job over here that is going to ingest the data into the Hopsworks feature store. Now, I've already done previous versions of this before, so I can immediately show you how I can now use this data, right, in, for example, an inferencing job. So what this looks like is a different notebook, right? Remember, we always have these three notebooks, right? Feature engineering notebook, training notebook, and online notebook. Now, what I'm going to do now is I'm going to run a inferencing notebook on the Hopsworks infrastructure, right? And what I can do then is I can go into Hopsworks and I can get the model that I have deployed already, right? So I did this before this webinar, obviously, but there's a model that has been deployed here already, right? A model that leverages the Neo4j data and that is now in production so that I can make real-time predictions using that Neo4j data, right? So that's what I'm going to do here now. I have my connection to Hopsworks. I get the model from the registry. I get a particular version of the model, and I get the deployment of that model, right? Because over here, right, I don't only have the model, I also have the model deployed, right? Now you will see that the model has been deployed here, but it's currently idle. What that means is that it's going to take a few seconds before the first prediction is going to yield results, right? So if I run this, right, so I'm basically giving it some inputs, right? And then I'm asking it to make a prediction. In this particular case, it's going to make one particular prediction based on one particular input. Once that is run, once that is going, you will see that here the model is now running, right? It turned from idle to running, and that will also mean that it will give me the prediction. And the prediction in this particular case is an anomaly detection score, right? I can do this one by one, but I can also do a batch of predictions. I can give it in a number of inputs, right? All of these, and it gives me a batch of predictions back. Great. Everything worked as expected. A little bit of a dance of joy happening on this side of this webinar. But I'm going to quickly wrap this up now, and hopefully we'll have some time for a couple of questions. What you saw in this demo is that we basically used Hopsworks to create this entire chain of pipelines, right, that leverages Neo4j, that leverages the graph data in Neo4j to make a full AI factory. And this AI factory is going to help us make better predictions based on that graph data in production, right? It's going to allow us to create these models end to end and deploy them as prediction services, as I showed you in that short little demo. I think this has a lot of potential, right? I think for Neo4j users, right, it makes it so much easier for people to leverage graph data in production. It makes it so much easier to improve the quality of those predictions by using graph data, right? So there's a lot of synergies here between, the power of the graph. I'm a firm believer of that. I continue to be a fantastic supporter of the entire graph ecosystem. But now you can actually use that graph, create a fantastic input for machine learning systems, using Neo2vec or some other embeddings that allow you to, create these vector-based summarizations of your graph structures and then input that into your different pipelines, right? So this makes it for much better AI, right? Much better machine learning systems, right? We're going to have better predictions that are in better compliance, better security, and they will be highly performant and highly available, right? It's going to allow us to create much faster time to value systems for your artificial intelligence and machine learning systems. And last but not least, it's going to be cheaper that way as well. I haven't talked about this in any detail in this webinar, but Hopsworks actually allows you to deploy this wherever you want to deploy it. If you're running Neo4j on a cloud infrastructure, great. If you're running it locally on your machine, great. If you're whatever you want to do deployment-wise and how you want to optimize this, we're going to be there and we're going to be able to make this happen on that infrastructure. So wrapping up, I warmly invite you to go to our community, have a play with the serverless version of Hopsworks if you want, right? Join our Slack channel, join our community, explore the tutorials on GitHub, right? So GitHub, Logical Clocks, Hopsworks tutorials, and you will have a world of fun exploring this in a lot of detail. I hope that's it for now. Anyone else want to chime in? Please reach out. You can reach me on rick@hopsworks.ai. A warm thank you from my side for you to attend, and I look forward to hearing from you in the future.